First rule if you're adding or subtracting fractions is you need a common denominator, right? If you already have that common denominator like we do here, then we can simply put this all together. We know the denominator on our resulting fraction is going to be x minus 4 in this case. As we subtract across the numerators, we get 5x minus 20 on top. The only thing left to do at this point is reduce. So how do we reduce? Well, we reduce by factoring further if possible. So by that I mean we can take a greatest common factor out of the top. We can take the 5 out. We take the 5 out, we got x minus 4 left. That's all over x minus 4. Now that I see those common factors shared of x minus 4, I can divide those out. In those positions, a 1 would be left, meaning my answer is simply 5. If you got common denominators, this isn't too bad. It's when we don't have common denominators that this gets challenging. So here's an example where we don't have common denominators. When we don't have common denominators, we need to set up two new fractions where we do have a least common denominator represented. So I'll set up two new fractions over here. I know I'm adding. And to figure out my denominators, well, I can look at basically the numerical values I got down here and the variables I got down here and figure it out. So between the 8 and the 12, what's the least common denominator going to be for the 8 and the 12? 24. Smallest number I can think of that both 12 and 8 go into evenly, 24. Now we have two factors of b over here, we have one factor of b over here. Because there's two factors of b, I need to make sure that I have at least that many in each of my new denominators that I'm making. So now that I know what the least common denominator is going to be, that 24b squared, I need to go back to these original fractions and think about what changes have taken place. Like originally I had this 8b squared right here, now I have this 24b squared. What change did I make? Well, I multiplied by 3, right? So whatever I did to the bottom, I have to do to the top. There was a 3 on top. So the new fraction here, there's going to be a 9 on top. And the changes that I made to go from this 12b here in the second fraction to the 24b squared here in the new second fraction, well, I multiplied by 2 to get to the 24, and I multiplied by b to get to the b squared. So multiply by 2b to the bottom, multiply by 2b to the top. You can do that. New numerator is 10b. Now that you have common denominators, we can go ahead and add through. Put everything over that common denominator of 24b squared. If we add through here, we've got 9 plus 10b on top. There's no factoring I can do with that 9 plus 10b, so that's my answer. All right, so if we're going to look at factors to help us build our least common denominator here so we can get two new fractions to work with, I would suggest taking your original denominators and factoring those out. R plus 5 is what it is. 2r plus 10, we can factor a 2 out. By doing that, we can see, in terms of just some nice clean numbers to work with, there is a 2 that's present in one of these denominators, so I need a 2 present over here in my least common denominator. I can also see there's factors of r plus 5. 1 here, 1 there. The greatest amount of times that occurs is just once, so I only need 1 over here in each. Now we adjust for our fractions in the numerators. Any changes that have taken place to create these new fractions, we got to make sure we're multiplying top and bottom over here. So in the first fraction, we multiply by a 2, right, to get to this 2r plus 5. Got to multiply by 2 to the top. New numerator is going to be 8. And then when you look at that second fraction, well, this denominator here matches that denominator there. So nothing changed. That means the numerator doesn't change. Since the denominators are the same, we can start piecing everything together as one fraction. We know denominator is going to be 2 times the quantity r plus 5. If we add through the top here, collect like terms, you got an 8, you got a 7, we got 15, plus a 3r. You need to ask yourself at this point if there's anything you can factor further between the numerator and denominator. In the numerator, we can factor out a 3. So if I take out a 3, I'm left with 5 plus r. That's all over 2 times r plus 5. And as we know, 5 plus r and r plus 5, that's the same thing. Common factors are shared between numerator and denominator. We divide those out. Ones hold those places, meaning all that's left is 3 over 2. All right, so we saw this on the last one. Having everything factored out in the denominator, that's helpful. I know since I don't have a common denominator here and I've got 3 fractions, basically I need to set up 3 new fractions over here. But in doing that, like I said, let's factor out the denominators that we have. This 4 minus x squared we can factor as a difference of 2 squares. So you got 2 minus x, you got 2 plus x. And now if you look at all the factors that are present in your current 3 fractions and try to build 3 new fractions over here, making sure all those factors are accounted for, well, the distinctive factors that we have, it looks like we just have like a 2 minus x and a 2 plus x, right? And at most, each of those are occurring just once in each of their respective fractions. So 2 minus x, 2 plus x, that's going to be my least common denominator. We think about changes now that need to be made, going from, we'll say, this first fraction now to this new first fraction. The change was from x plus 2 here to the new one. We multiplied by 2 minus x, right? So I need to take a 2 minus x here, multiply that to the bottom, multiply that to the top. I might as well, as I do that, distribute this 3 through, so I get 6 minus 3x. Okay, the great change that was made for this second fraction here to the new second fraction was we multiplied on a 2 plus x to the bottom. So multiply that to the bottom, multiply that to the top. You've got 3 times that quantity, so if I distribute the 3 through, it's 6 plus 3x. And finally, for the last one stays as 3x squared. Right, we know that because this bottom part didn't change. So put it all together. You got to be careful as you put this all together because you are subtracting across. So denominator we know is going to be 2 minus x and 2 plus x. But subtracting across the top, notice here I'm subtracting what is basically a binomial expression. You've got multiple terms, so I do have to carry this negative through. I do have to change these signs when I carry that negative through. And technically I'm subtracting this 3x squared, so yeah, change that sign, but we already know we're subtracting 3x squared. If you collect your like terms now working across the top, notice the constant values, 6 and negative 6, they subtract out. The x terms, negative 3x, get negative 6x. You've got your, well, plus the negative 3x squared over here, or just minus 3x squared over here is the remaining term. If any factoring is necessary, go ahead and do that. Obviously, we know the bottom's factored. But it looks like on top, we have a greatest common factor of, well, we could say 3x, but since they're both negative, let's say negative 3x. You take the negative 3x out. If you do that, you're left with 2b plus just x. And how about that? We've got a couple of 2 plus x's we can divide out of this, meaning all that's left is negative 3x over 2 minus x. All right, so once again, we don't have the common denominators. We've got to set up the two new fractions. To get started, you want to factor your denominators. Make sure you have all the factors out in the open to play with. So, factoring the denominator here. Got x times x, got 3 times 2. Make that a negative 3, make that a positive 2, that should work. Factoring the denominator here. Now we got x times x. What is it, 3 and 2? Be negative on both, right? So all the factors are out in the open to play with. As you look at all the distinctive factors that need to be included in your least common denominator here. Notice you got an x minus 3 here, x minus 3 here. We're going to need to include an x minus 3. Got an x plus 2 in at least one of these, so we need one of those. And we have an x minus 2 in at least one of these, so we got to include one of those. We're going to have 3 factors that make up our least common denominator. So if that's the case, I need a little more room. I'm going to set up my fractions down here. Okay, so 3 factors. You've got x minus 3. You've got x plus 2. You've got x minus 2. The big changes that we need to make. Well, to this first fraction, let's see, we go to the new fraction here. What's missing from this one up here? We're missing an x minus 2, right? So in theory, I'm multiplying an x minus 2 down here, meaning I'm multiplying by an x minus 2 up here. If I multiply by that x minus 2, I can FOIL things out. FOILing things out, I'd have x squared. Outside is negative 3x, inside is negative 2x, so that's negative 5x. Last, you got negative 2 times negative 3, so plus 6. And then comparing for our second fraction, as far as what's missing from this new one compared back to the old one, we're missing an x plus 2. So I need to multiply that on. If you multiply that onto the top, FOIL it out. X times x squared. Outside would be 2x, inside would be 3x. So that's going to give you positive 5x. And last would be the 3 and the 2, so positive 6. Keep in mind, you are subtracting here. So subtracting this entire quantity means I have to distribute that negative through to these terms. So when I put this all together as one fraction over this least common denominator, if I combine the like terms on top, I should notice with the x squareds, they will subtract out. The 5x's, they're both negative, so that's negative 10x. And then the 6's would subtract out. Meaning that's as far as I can go, because there's nothing left to factor, so there's nothing left to divide out. You got your answer.